Imagine saying that a terrestrial conservationist has to sacrifice thousands of individuals just to understand the species community and abundance of each species. Well, that's exactly what fisheries managers have to do. Instead, I'm building a model to classify fish species using hydroacoustic data without ever actually having to see the fish. Hydroacoustic data is like sonar. It's used to see objects underwater, and I use the strength of different frequencies of sound reflected off the fish to classify them. And to do this, I build a custom recurrent neural network. Basically, this takes a sequence of detections or reflections of sound from one individual and assigns a classification to this sequence. I chose to build a custom model because the hydroacoustic technology needed to classify species has only recently been developed and is still very experimental. This means there really aren't any publicly available models to use or for me to base my model off of. This made the model building a bit more challenging because I had to start from scratch to figure out what type of model would be useful and the specifics of the model, such as the number of layers or how much regularization to apply. Currently, our model is able to classify 2 fish species, lake trout and smallmouth bass, to a reasonable accuracy level. On an unseen test set, it correctly classifies individuals 84% of the time. There is still room for improvement as we tinker with the hyperparameters and the model structure. Also, it is important to note that the data this model is trained on is not on free-swimming fish, but on individuals tethered to the boat. We plan to collect a data set to test this in the very near future, but currently we don't know how well this will translate. Overall, though, this model represents a significant advance in automatically classifying fish species through hydroacoustics. When this model has been expanded to more species, it will be integrated into stock assessment, biomass, and abundance models. This will allow for classification error or uncertainty to be accounted for in these models. And eventually, a model like this should replace the need for current invasive and lethal monitoring of fish stocks.